environmental exposures and disease outcomes and risks. In epidemiology, you'll understand, everyone will know epidemiology is the study of the distribution and determinants of disease in human populations. Well, here the emphasis is the spatial distribution and determinants of disease. And it is to public health, or should be to public health, what actuarial analysis is to the insurance industry. And that is because we can actually provide rigorous data and accounting of how there are spatial variations in disease. And that is very important for informing locally tailored interventions, because solutions that are one size fits all don't accomplish the same gains across the population. In fact, they can increase the differentials between those who are advantaged and those who are not. You'll all know this map about John Snow. Everyone says he was the first epidemiologist, and I disagree. He did do this. He counted up cases in relation to pumps and water sources in London, and that was terrific work. But he didn't use rates. And the first person really to use rates was Durkheim when he was looking at suicide as it increased with industrialization across France. So the rates are what defines epidemiology, because you're looking at the emergence of something against a background population or over time. Snow didn't do that, but we combine Snow with the work of Charles Booth, who mapped poverty in London in the late 1800s. The legend on the right is the original legend describing classes of people and poverty distribution across London at that point in time at the turn of the century. So we're basically taking the counts or the points that have been identified by Snow, and we're trying to understand them against a backdrop of, say, social disadvantage, but also things that are contextual, that are not human, or the things that we might put on the ground, the built environment, for example. So modern living does produce a lot of chronic disease. And chronic disease is very costly to pay for and to manage. It's psychologically and emotionally trying. It costs the health system a lot of money in acute care. And because this is the Heart Foundation, I've listed these important outcomes. I'll be dealing primarily, though, with cardiometabolic outcomes, so I include diabetes or glycemic disease along with the cardiovascular outcomes. But all of these chronic disease outcomes, including certain cancers related to lifestyle, are associated with these primary 4 risk factors. And those risk factors are differentially produced across populations. The levels of those risk factors vary spatially. Now, in chronic disease, treatment capacity is being outpaced by incidence. The costs are not sustainable to healthcare systems. We just cannot keep building hospitals and funding more and more medicine for extremely expensive acute care interventions. And yet we have a situation where prevention remains the poor cousin to the perceived priority of acute care. I'm hoping to convince you that a greater investment in prevention is a worthy and important undertaking by providing you spatial data that indicate how disease is produced differentially. So what can we do differently? We need clinical and behavioral intervention. These are necessary, fundamentally necessary, but not sufficient. We need to differentiate lifestyle from behavior. They're not the same thing. Lifestyle is the patterns of non-volitional behaviors in which we all engage, and we do because everyone else does them. We don't think about them. We're socialized into them. You go to different parts of the world, you will see different lifestyles because people are socialized into living differently. So it's not the same. Now, what shapes lifestyle then is the environment. If you can understand what is shaping a style of life, you have the capacity then to intervene on behaviors that are the output of lifestyle. And that's what we're doing with this research, is trying to understand environmental factors that shape risk and disease. There is a growing emphasis. In fact, over the last 15 years or so, we've seen an exponential increase in the number of publications that deal with health or place or geospatial epidemiology, just exponential. It all began around 2000, and it's showing no signs of stopping. So this kind of work is increasingly recognized. It's important to understanding how and why. It's relevant to policy and practice, and it's relevant to treatment and prevention. Now, all of these features, all of these outcomes have been linked to features of places. All of them, from social pathologies to psychosocial and mental health and health behavior, self-reported health, all the way down to incidence and all-cause mortality. So location matters is the point of this slide. Jeffrey Rose was someone I studied as I did my doctorate, and I struggled with his maxim a great deal, and it took me a few years to really fully understand it. But the causes of cases are not the causes of incidence at all. People get lung cancer because they smoke, and they might get heart disease because they smoke. Why is incidence different in different places? Well, it's because people smoke differently in different places, but the question is, why do they smoke differently? What are the policies around tobacco, around cigarette packaging, around health promotion in different places? So Rose is saying that incidence as a phenomenon is shaped by more upstream or distal factors than the causes of cases themselves. We, in our work, differentiate risk factors from risk conditions. You all know what risk factors are. Risk conditions, on the other hand, are the properties of environments that exacerbate inherent vulnerabilities in the people exposed to certain features of places. So we talk sometimes about noxious environments, adverse environments. These environments actually shape outcomes. So if you have a genetic predisposition, say, to heart disease or diabetes, whether or not you get heart disease or diabetes is going to be a function of where you live, the environment in which you live. You may live your entire life having a genetic propensity to some kind of disease and never actually express that disease because your environment doesn't support the expression of that phenotype. This slide positions, say, two communities, could be two states, or even nations. These are risk factors for heart disease. We have a very small difference in mean systolic blood pressure and a relatively small difference in BMI. Very little difference really between these communities. But if you compare community B, which is unhealthful, relative to healthful community A, you have about twice as many cases in the high-risk tail of this distribution. And this is the realm of medicine. And this is what medicine deals with. But for this very small difference in a mean, for an entire population, you can end up with more than twice as many cases needing to be dealt with by acute care intervention and ongoing management. This slide similarly shows you that for a given mean, it doesn't even have to vary, but the variance can vary. So you have a much broader curve for unhealthful community B. You have over 3 times as many people in the tail end of this distribution needing to be dealt with by medicine. So the point is that if we understand what shapes the position of the mean and what shapes the variance of the mean, we're in a position to intervene on those factors and then prevent substantial numbers of people ending up in the tail of these curves. This is a simplified model that we apply in our work. We situate risk and disease as a phenomenon of behavior, psychosocial factors, and environmental risk conditions. Now, I'm going to talk to you mainly about the third pathway, this one, but I'll cover some of the others. Now, depending on where you live, which shapes then how you live, your own trajectory of health across the life course will differ. It differs as a function of your environment. So if I were to measure you just annually for, say, 25 years here as an individual living in a particular area, let's assume you don't move, and I'm measuring you over a long period of time, and this area in which you live is different from this area, which is different from this area, your trajectory of health will be very different. So the health trajectories are grounded to the environments in which people live. This is what you end up with. And this is real data. Diabetes cases per 1,000 person years. The action is down here in the poorest neighborhoods, but what is the point? What you see is that health varies between areas, between the poorest and the richest. Within an area, whether poor or rich, individual SES or wealth is shaping or influencing the distribution of disease. So disease varies between and within places. With GIS, we're in a position to understand what's going on around you, and we can start to characterize environments. If you're here as a survey respondent, we can then understand what kind of housing you live in over here. We can understand your accessibility to healthful and unhealthful foods. We understand the things that dictate your capacity to transport yourself to different places and perhaps active transport. We understand land use around you. And we can actually, we can actually nest you as an individual survey respondent. We can nest you in terms of the characteristics of the people who live around you as well. If we're to do this, we have choices to make about how we characterize your environment. Each of these red dots is a point, is an individual. It could be any one of you. Now, we can nest you, say, within a collection district, a census tract, or anything like that that's administrative, which isn't particularly helpful when people living over here, or let's say here, stand to be more like the people over here than they are the people over here. So these are artificial boundaries and distinctions. They're not meaningful differentiations. We can look at what's around individual street sections, and here we're starting to get somewhere. We can put buffers around you. So every blue point here is, say, one of you. And we derive a buffer around where you live, and we measure the phenomena in which you reside. More meaningfully, though, we can take a network buffer and go out from any single point, say 500 meters, 1,000 meters, the scale can vary, but we go out in terms of accessibility. So these buffers are irregular, they're not nice and round, but they actually are meaningful expressions of what you have access to within a certain distance of where you live. And you can do them at different scales. So the work, this body of work really began a long time ago. It began in North Carolina, and began to move along better in Montreal and then Adelaide, and now we're in the ACT. The idea is to look at environmental influences on population health, to understand the relationships between health and environmental exposures. And I don't mean just what public health does, which is to say public health monitors trends in disease, okay, or risk factors. It monitors outcomes. I'm talking about monitoring relationships between a predictor and an outcome. Not the outcome only, but how the relationships change over time in response to policy or practice level interventions. So it involves multi-level analysis, which I guess many of you are familiar with. The ultimate aim is to support evaluation of policies and programs on population health, and really to provide an empirical basis for decision-making at the highest levels. This is a representation of a geographic information system. We've got measures on the physical environment, the built environment, many different kinds of measures, social environment, health data, and a geodatabase, all integrated together. I'll just give you a few examples of these. Now, okay, that's all right. Okay, I know which presentation we're on now. There were two. This was the first, not the second. That's okay. The first two examples then will not be heart disease, but they'll be illustrative, and the third will be heart disease. But the physical environment is relevant to cardiovascular health because pollution, nitrogen dioxide, particulate matter 2 to 5 microns, is associated with CVD events. This has been well documented, and here is a statement from The Guardian in early 2016 indicating that within the first 8 days of that year, London had exceeded its annual air pollution exposures within that very short period of time. So what we did in Montreal is we used measurements of nitrogen dioxide along freeways, and we found that the exposures were greater within 200 meters of a freeway. We then used a provincial database of about 100,000 births, and we analyzed birth outcomes for women living within 200 meters or greater than 200 meters from a freeway. And lo and behold, the odds of preterm birth and low birth weight were greater, not small for gestational age, but these are point estimates and 95% confidence intervals. And for epidemiology and population health, these are important relationships. In terms of the social environment, we found that perceptions of neighborhood security measured by the police across the island of Montreal were inversely related to small for gestational age outcomes. You might say, well, okay, these confidence intervals are relatively big. You're close to 1, but the point is there's a linear trend, and that the most favorable perceptions were related to the lowest level of risk. So for the built environment, and here we have our heart disease examples, this is an analysis of 845 census tracts in Montreal, 1,200 fast food outlets, 30,000 cardiovascular deaths occurring across a 5-year period. We accounted for every possible exposure. We drew DAGs. We accounted for area-level confounders and individual-level confounders. And what you have is a relationship where for each 10% increase in fast food restaurant density, the odds of death from CVD rose by 40%. This is some work done by our colleagues here before our team arrived. It was done just a short while ago, and it shows that cost per person and admissions per person for circulatory disease were inversely related to neighborhood walk score. The walk score is a measure of walkability in a sense. So areas that are more walkable had lower costs per person on admission to hospital for CVD events and lower numbers of admissions per person. But as you'd expect, given the healthcare system in Australia, there is no difference or no relationship for cost per admission. You see the usual SES variation, but the point is the direction of the relationships. We showed in Montreal that fast food outlets were inversely related to area level or neighborhood SES, and that the fruit and vegetable outlets were positively related to neighborhood SES. We looked at schools. We looked at fast foods around schools in Montreal. And we have about 1,200 schools here. Again, 845 tracts and about 3.5 million residents. And what do you see here? This is one of my favorite slides because it shows that as neighborhood income increases, so does the odds of having no fast food within 500 meters of a school. This is stratified on commercial density. It's a monotonic relationship for each stratum. And what is it telling you? It's saying that our local councils have a capacity to influence what kinds of businesses go down on the ground around the schools that our children are attending. And the relationship varies directly with socioeconomic status. And it's a very powerful slide. So it means that there's a capacity, at least in theory, to intervene at the local level to deal with the councils who are allowing these fast food outlets to be placed around schools. In Adelaide, we replicated that same analysis. So it wasn't a Montreal phenomenon. It was as applicable to Australia as anything. And that leads me to some of the fundamental problems in how we do what we're trying to do. This whole field of work began when people started looking at areas defined by socioeconomic status at the administrative level. Strong evidence linking census tract SES to all of these things. And if you look at these things, we're going in a progression from behaviors to overweight, obesity, to psychosocial factors, to having disease, then to incident disease, then healthcare utilization, and then the consequences of disease. It's a progression of outcomes. Now that evidence is fairly strong, but 95% of it is cross-sectional. We then look at how does census tract SES relate to context? These are all contextual things, they're human-made. So we're dealing with opportunities for active transport, opportunities for recreational activity, parks, green space, neighborhood walkability, fast food outlets, strongly related to SES, as I'd shown you in those two other slides. Now, when we then ignore SES, which is why it's blacked out, when we look at the relationship of these things to this progression of outcomes, we see the relationships start to vary. They're not strong, they're not robust. Behavior is related to these things, psychosocial to a degree, clinical disease to a degree. When we get into incidence over time, healthcare utilization, consequences of disease, there's almost no evidence. And that is not controlling for SES. When we do control for SES in looking at the relationship of these things in white to these things, the relationships become even more unstable. So what this means is that we need to do more longitudinal research to better understand the contributions of contextual factors, the things in white, to these kinds of outcomes. Now, when we got to Adelaide, we became involved with the Northwest Adelaide Health Study, and this is showing the region of Northwest Adelaide. And there's a statistical clustering of people with prediabetes and diabetes in this area. It's a hot spot, and this is a cold spot. This is on the coast, by the way. And that's a descriptive phenomenon. You can describe it. You don't understand what is really shaping it. So we started to work with the cohort, which involved about 4,500 people tracked over 10 years. And we geocoded everyone in the cohort. So this is one of the first things we did, was looking at incidence over 5 years, controlling for everything you can imagine. Public open space was inversely related to diabetes. Fast food outlets were positively related to hypertension, and the ratio of unhealthful to healthful food was positively related to abdominal adiposity. So here we've dealt with the gap created by the lack of longitudinal research on how place affects health over time. That was interesting, but we wanted to do some particularly novel work, and that involved looking at norms. So we take, for example, the food environment, the urban form environment. We look at norms somehow, I'll tell you how, and we control for this, which is really important because in many studies of this nature, people don't account for SES. And I've shown you that area SES confounds the relationship of these contextual things as they shape outcomes. So we accounted for SES. We used a separate survey, a statewide surveillance system, South Australia monitoring and surveillance system. And that's like the US Behavioral Risk Factor Survey, where everyone is surveyed across areas at random. So you receive a more or less representative perspective on risk factors distributed across the population and geography of the United States. So it was like that. So using that, this SAM system, if this is you, this dot in the middle of the network buffer, we could then determine the prevalence of obesity in the area in which you lived. And that prevalence of obesity varies by person. So what we're interested in is, does that shape a health outcome over time beyond what's on the ground? So we looked at urban form expressed by walkability, and we took these area level norms for overweight obesity. We found that there was an inverse relationship between walkability and change in HbA1c over 10 years. And norms, actually, even accounting for urban form, were very strongly related to increasing HbA1c over 10 years. And that's accounting for SES and all the individual level confounders. So that work forms former PhD student, now assistant professors, area for personal growth across the next 20 years or so. She'll keep going with this work. But it's incredibly novel because nobody else has done it. So we're showing what you all assume is obvious, which is you behave in the ways in which other people behave, and because that's just what you do. But those behaviors, which is to say lifestyle as shaped by the environment, does shape your trajectory of health over time. Importantly, when you look at the worst condition, which is low walkability versus high walkability, norms don't influence the relationship over here. But where you have a poor or an adverse environment, having more healthful norms, actually in the yellow line, lowers the level of risk. Worse norms exacerbates the level of risk that's already there imposed by the environment in which you reside. I'm not going to deal with this. Well, I am going to deal with this, and some of you will get it, but I'll speak it through for everyone. Norms relate to increasing HbA1c. We wanted to look at how individual level physical activity mediated, accounted for, causally accounted for that relationship. What we found is that recommended levels of physical activity accounted partially for the increase in HbA1c over time. So physical activity at a recommended level then was inversely related to norms for obesity, was positively related. What do we got here? Norms, obesity norms are related to physical activity, that's right. And then we move up here to path B, and we have physical activities related to HbA1c. And when we put the indirect effect into the model, we have the statistically significant indication of mediation. So we know then that what you do as an individual can actually account for an adverse influence on what your health would otherwise be. So if you're engaging in healthful behavior, that's great. If you live in an adverse environment, if you're not, well, just think about it. So I've shown you how the environment functions as a risk in ascribing risk conditions to you. We'll move on then to looking at behavior and lifestyle and psychosocial factors together. And I had a brief chat with Professor Sir Harry Burns before I came in, and interestingly enough, his work deals with some of this as well, and he speaks tomorrow. But the work he's doing is enabling people to feel better about themselves when they're in particularly adverse conditions. Now, what you have here is fast food density on the x-axis, and then we have the odds of eating at a fast food restaurant within the area in which you live. There's no relationship for people who scored low on this psychosocial measure, but for those who scored high, we see a very significantly greater likelihood of actually eating in a fast food restaurant when you're so exposed to a fast food restaurant. And the BAS is what's called the behavioral activation system. It's a psychological measure of your capacity to engage in very independent thought, people who like to do things because they're new and exciting and they just want to do something. So it deals with those kinds of effective measures. We looked at mastery as well. Now, let's just systematically deal with this. Let's just look at this one, the fast food outlets, and we stratify your exposure in terms of low, medium, and high. We have a relative risk of a high count of cardiovascular risk factors over here. We've standardized mastery, and what you see here, say for a relative risk of 0.8, it means that people with mastery, one standard deviation greater than the mean, have a 20% lower likelihood of having the same number of risk factors as someone with average levels of mastery. So mastery relates to your level of risk. The degree of control you perceive yourself to have in your life relates to risk. And of course, its effect, as you see here, is strongest in the most adverse environment. In a low-risk environment, there's no effect. But as you move into medium and high risks, or the higher tertiles, the impact of your personal mastery becomes more important. So it's not just where you live. We look at where you go and the routes you take as well. So a simplistic expression of active transport is portrayed by putting someone in an administrative area. We can put a buffer around that person, whether it's Euclidean or network, it doesn't really matter. We can characterize the places you go, for example, where you might go for sport or social engagement, and where you might go to work. And we can characterize all of those places that you frequent in your lifestyle. We can also look at the routes that you take to get between those places. And this analysis here by one of my PhD students in South Australia uses Montreal data. It's a big survey from the Ministry of Transportation in the province of Quebec, and it involves 400,000 movements, 65,000 households, and about 165,000 people, okay? So it's a big survey, and what it showed is that the likelihood of individuals engaging in a minimum level of physical activity through active transport was related to the route. It wasn't necessarily related to where they lived or where they went or where they worked. It was related to the characteristics of the route. And this has implications for urban planning. So you might decide you're going to cycle or walk if there's green space, if there are parks, trees, water fountains, that kind of thing. All of this encourages people to live healthfully. Now, we started here at the individual level, looking at behavior, psychosocial factors, stress axes. But we need to, consider a continuum approach extending to the population. And a body no less eminent than the U.S. Institute of Medicine has publicly tabled their position that environment and policy changes are the most promising strategies for controlling obesity and improving diet and physical activity. And that was 10 years ago. So then we need to account for the community level influences, the composition of your population, the context, what's on the ground, what we build, the connections between these things. We allow that these things are all going to vary by region, so what's going on in ACT will be different from what's going on in Victoria, New South Wales, and Western Australia. So you have one national policy and it plays out differently in different places because the contexts are different and the people are different. So we put all of this into a framework. We consider the macrostructural over here, and we see a need for resources and opportunities to be provided at all of these different levels. So at the environment, regionally, education, employment, at the community level, living conditions, minimal standard, reasonable health care, at the individual level, social support. Now, interventions that engage in initiatives to deal ecologically with environments and groups of people and environments have been found to be incredibly cost-effective. And a return of 14-to-1 on investment is just phenomenal. And 8-to-1 in a cost-benefit ratio is just phenomenal. So we need to do more of this kind of work. So we're building a geospatial health hub at the University of Canberra. That's why 6 of us came up from South Australia about 18 months ago. The hub is founded on a geographic information system I had begun in Montreal. And that was the prototype, and we're refining it and expanding it here in Canberra. And we have a formal arrangement with an industry partner, Esri, and Esri is the world standard in geospatial analysis and databasing. And they're supporting our health hub, so we're in the process of the build right now. And we need the health hub because typically in doing this work, what you start with is on the left. You don't have metadata, nothing is standardized, you're poorly organized, and you can't do comparative work. So all this messy data is on a server somewhere, and you might try to develop a metadata layer. But what we're doing is imposing a database management system with Esri. We are using a comprehensive indicator classification system developed in Montreal that goes through a typological hierarchy from a construct down to a measurable indicator. And so it allows me to say, well, I found this relationship, and you can say, well, why did you choose that outcome? And I'm not left with saying, well, because it gave me statistical significance. I can say I use that outcome because I have a conceptual typology that takes me down to that measure. It's based on the German national system for classification of social indicators, and it's embedded into the geographic information system. So you can search on a concept, a construct. It moves you down hierarchically to an actual operational form. So we're imposing web services, and we'll have a portal, and it will all be ISO standard. Now, it allows for comparative work. So we can compare cities in Australia, states in Australia. We can do international comparison. And it involves everybody using, basically, the same indicator classification system, the same standards for metadata. And why is it important to do comparative work? Because you have different lifestyles in different places. You have different policies in different places. So if in Kuwait, where we're working now, and in France, in Paris, in Montreal, in New Delhi, where we're working right now, we'll have different measures of, say, a health outcome. We'll have different measures of, say, environmental context. But typologically, these measures can be related such that what we're analyzing is the same system of relationships, but in different places. And that allows us to speak to policy implications. There's some collaborators. Okay, so I'm going to skip there. My last slide and a summary. What I've tried to convince you of is the influence of the environment on lifestyle. I've shown you associations between environmental factors and important population outcomes. I've shown you some work that deals with the mechanics or the pathways the mechanism by which those effects are expressed through behavior, through psychosocial factors, and so on. And I'm trying to convince you that these environmental exposures are incredibly important to policy and practice because it allows for tailoring of interventions. It allows for interventions, say, in the hospital, where you have if you're automatically recording an address in a standardized form, and my colleague Neil Coffey likes to say, if you call up Domino's Pizza and give them your phone number, they know where you live. You try to enter an address into a hospital database, and it's all wrong. You know, so how is that Domino's can do this and hospitals can't do this? So, you know, if we enter your address into a hospital, that is your most recent address. It's automatically updated into a system. We then have a record of where you've lived, where you live now. We can understand the phenomena to which you've been exposed that will shape your lifestyle and your health outcomes. Ultimately, this is about putting resources on the ground, more healthful living conditions, reducing toxic or noxious environments where people find themselves to be hopeless and therefore give up a capacity for behavioral self-regulation and succumb to depression, anxiety, all kinds of psychosocial pathologies. It's about giving people the resources they need. And that's really the crux of it. So thank you for your attention.
Fantastic. Thank you so much, Mark. We've probably got time for a couple of quick questions. So we've got someone up.
Could I please ask two quick questions about data collection? The first one is, with people moving around so much, if a person dies in the area that you're studying, how do you know it's related to factors in that area where they've lived for the past year versus where they were for the 60 years before that? That's my first question. And my second question is, with the walkability scales, do you actually walk the areas before you rate them? Because in Canberra, sometimes it looks like it should be quite walkable, but actually the paths are really uneven, or at night the lights aren't light enough to be able to walk safely. So do you take that into consideration as well?
I'll answer the latter question first. And, you know, that is that the team we're working with has indeed looked at walkability, done work on safe routes to school. But in that, I would say that there are many ways of characterizing what is walkable and what is not. So there's no standard measure for assessing walkability in a comprehensive way. Often it's a measure of urban form, where connectivity, intersection density, those kinds of things are what defines walkable, because the idea is people don't have to traverse a long route that goes nowhere and then walk back again. So to some degree, I can answer your second question. In the first question, we'll never be able to understand the cumulative risks accrued along the life course through environmental exposure until we're able to deal with accurate addressing and thus geocoding and the integration of those data into a big data system. It's big data. My analogy for what you're talking about is occupational epidemiology, which I have some knowledge of, and that's where, if, say, you work in a shipyard and you're a welder and you're exposed to the intake of noxious welding fumes for 8 hours a day, you get a certain grade for risk. We can do the same for an environment. When that welder goes on to a different job, say maybe steel fitting, and doesn't have to do all of that welding, the risk level goes down. But then we have a measure of risk, say, accrued over 15 years. We have another measure of lower risk accrued over another 10 years. So you get a cumulative risk score as you go. Now, occupational epidemiology does this all the time. We can do it in spatial epidemiology if we have the data that you're asking about. Do we have records of where people have been? You can do crude you can do crude scoring of what kind of area people have lived in the past. Self-reports aren't highly reliable, however. So the idea is that a national data system in Australia for, say, recording patient information in hospital systems and Medicare needs to account for storing subsequent addresses. Because what there is usually is a current address, and that's considered to be the address. It might not be the address, even though people ask you, is this your current address? But we want to know about the past ones, too. So, I'd love to do what you're suggesting for your question number 1. It's not possible yet, but we are getting there. All right.
Okay. So last question, Liz.
Yeah, thanks very much. It was a great talk. Over here, other side. Liz DeChastel from the Australian Local Government Association.
Yep.
So our association represents 537 local governments across Australia. I'm just sort of keen to see, you've put a lot of issues up there. What would make the biggest change? What would you say to local governments that they could do to make the biggest or the better health outcomes for their community?
Well, if I could answer that, I'd be giving you an across-the-board response that is one-size-fits-all local governments. And like a statistician, I have to say it all depends. It depends on the context of the area that local government is dealing with. We had a big project in Adelaide, an NH&MRC partnership grant, working with local councils across northwestern Adelaide. And they gave us input on what they wanted us to measure and analyze, and we did it and reported back to them. And the relationships varied because the composition of the people in their area varied. What was on the ground varied. Sometimes it was urban sprawl, sometimes it was pretty dense commercial area interspersed with residential area, so it does depend. But the advantage of that work in South Australia was that the state had mandated that local governments be responsible for the public health implications of every single urban planning decision. So there was a new Public Health Act passed that required all the local councils to be fully accountable. And so we're in the right place at the right time being able to work with them, but I have to say it does all depend.
Fantastic. Please join me in thanking Mark. Thank you. I'd like to introduce Annie as we start some of the abstract talks now. I'd like to introduce Annie Kentwell, who is the Active Living Coordinator with the Heart Foundation. She's going to get you all to be physically active for a moment while we set up. Okay, so we're going to be running through some presentations now. We've got each presentation is going to be about 8 minutes long. We'll have about 2 minutes for questions, and then we'll move on from there. So I'd like to introduce Amardeep Kaur. She's from John Curtin School of Medical Research. She's a postdoc there, and that's what we're looking at on the screen right now. So let's go. We've got 8 minutes.
Thank you for the introduction. Hello, everyone. Thanks for coming for my talk. So today I'm going to talk about importance of evaluating the platelet receptors and inflammatory markers in cardiac patients. So I'm going to start with introduction of the role of platelet receptors in thrombus formation. As you can see that whenever the platelets are at resting conditions, they encounter the exposed wall-Willebrand factor, collagen, the receptor present on the surface of platelets, they started with their interaction leading to the activation of platelets, and then with the concomitant activation of coagulation pathway leading to the clot formation. The importance of receptor here is the receptor interaction with their ligand actually initiate or triggers an intracellular pathway which leads to the platelet activation. Many studies so far have shown that the platelet-specific receptors, GP1B95 and GP6, are critical for initiating the platelet activation under high shear rates. And interestingly, the levels of these receptors on the surface of platelets are regulated by metalloprotease-dependent actodomain shedding. What does that actodomain shedding mean? The actodomain is the main area where the receptor interacts with its ligand. So the shedding of this receptor leads to the loss of the receptor function. Interestingly, whenever platelets get activated by interaction with the ligand, it would lead to the activation of metalloproteases, and these metalloproteases, such as ADAMs, they then cleave this region and leads to the soluble fragment or soluble ligand binding fragment of these receptor into the plasma. That means that, and also under high shear rates, or shear means the flow rates of the blood, there is a shedding of this receptor, specifically GP6, even without activating the platelets. That means that the loss of this receptor is actually irreversible because platelets are anucleated, they won't be able to replenish it. So, in our lab, we made certain assays by which we can quantify the shedding of these receptors. We have made certain antibodies that can detect the ligand binding domain as well as the remnant domain. So using these antibodies, we can actually detect the shedding of this receptor using Western blot. As you can see that under resting conditions, if you Western blot the proteins of the platelet, you can see that most of the GP6 is intact. However, under activation conditions of different types, there is a shedding of the receptor or appearance of the remnant fragment. Also, this ligand which is being released, this fragment which is being released into the plasma can be detected using an ELISA-based assay, which could indicate that a high level of soluble GP6 indicate more shedding of this receptor. Also, with this actodomain antibody, we can detect the intact level of these receptors on the surface of platelets using FACS-based assays. So, as I've shown that under resting conditions, the platelets are having intact GP6, we were interested to know what are the levels of soluble GP6 in a healthy population. In a cohort of 79 healthy donors, we measured soluble GP6 level and seen that in 99% of the population, the soluble GP6 levels are less than 50 nanogram per mil. Also, in an independent study at UK of a cohort of 512 people, we see that there is less than 50 nanogram per mil soluble GP6. Now, we were interested to see what is the correlation between the levels of these receptors and platelet function. As we all know that the platelet function is in hemostasis and thrombus formation, we were interested to see whether the levels of these receptors, they were correlated with the bleeding outcomes. In that case, we have studied the bleeding outcomes in a cohort of 16 individuals having unexplained bleeding. As you can see that there is a significantly low levels of GP6 receptor on the surface of these platelets, indicating that there is a correlation between GP6 levels or receptor levels as well as the bleeding outcomes. So now, can we use this as a marker to predict the bleeding risk in patients which are at the risk of bleeding and thrombosis? For that, in current study, I'm going to talk about the importance of measuring the levels of these receptors in the patient at the risk of bleeding, specifically the patient who was receiving left ventricular assist devices. We know that in the end stage of heart failure, the patient have to be assisted with the pumping of their blood using the LVADs. So the LVADs nowadays, there were two technologies that are being used, but the continuous flow LVADs are the ones which are frequently used. However, the use of LVAD, continuous flow LVAD, is associated with the long bleeding risk, and the bleeding risk could originate because of the anticoagulation and antiplatelet therapies that have been given during the surgery, as well as the disruption of wall-Willebrand factor. So, as I mentioned before, that the shedding of these receptors can occur due to the high shear rate. I would like to mention that in a continuous flow system, the shear rate is interestingly very high. As you can see that even in the blocked vessel or stenotic vessel, the maximum shear rate is 19,000. However, in a heart-made system of continuous flow, the shear rate is 50,000. So we were interested to know whether, so in these patients, the bleeding outcome is coming due to disruption of wall-Willebrand factor, which is known to interact with GP1B95 receptor, and that occurs due to, it is known that the wall-Willebrand factors can be disrupted at high shear rate. In the current study, we were interested to find out what is the role of loss of GP6 receptors with respect to the bleeding outcome in patients that are receiving continuous flow system. For that, we studied the levels of these receptors in the people who were already implanted with LVAD. And we've seen that there is a significantly low levels of receptors on their circulating platelets and also high levels of soluble GP6 in their plasma. In another study, we were also interested to find out what are a time-dependent study where we can see that what are the soluble GP6 levels before implantation of LVAD and after implantation of LVAD. So we monitor the soluble GP6 levels over a period of time of 360 days for 7 time points. And in this case, we also know the outcome of the implantation of LVAD. So we divided the patient on the basis of their bleeding outcomes and no bleeding outcomes. As you can see that when the patient having bleeding outcomes have significantly higher levels of soluble GP6 as compared to the patient having no bleeding outcome. This indicated that the soluble GP6 levels are important for the bleeding in these patients. So we were also interested, so we then draw the data on the basis of their initial or day 0, or what I call the baseline soluble GP6. As I mentioned before, that we know that for the healthy individual, the soluble GP6 levels are less than 50 nanogram, and for any levels higher than that might indicate that there is a shedding or more shedding of these receptors. In that case, we have seen that the people having day 0 higher or before implant higher soluble GP6 levels, they tend to bleed more as compared to the people which are having the soluble GP6 within the normal range. And also, the people having the soluble GP6 within the normal range, when they were implanted with LVAD, we've seen that the levels of GP6 receptor, soluble GP6 increases in the plasma, indicated that the high shear in the LVAD devices are actually leading to more shedding of these receptors. So our study indicated that, so with the soluble GP6, prior to implantation, we can stratify the patient of which are at the risk of bleeding. So far, all of these patients are receiving 2 to 3 antiplatelet drugs before surgery, and that means that there is a clear rationale by which we can customize this antiplatelet therapy for at-risk patients. As you can see that the soluble GP6 levels are higher in this patient before implant. We have also studied the inflammatory markers in these patients, and we have seen that there is an increase in inflammatory like granulocyte as well as the inflammatory marker, indicating that inflammation may have been contributing to high soluble GP6 level in these heart failure patients. So with this, I want to conclude that GP6 seem to be unique and a specific platelet activation marker, and there is a clear rationale in measuring soluble GP6 level to predict thrombotic and bleeding risk in people who are receiving LVADs, and this may guide the anticoagulation and platelet therapy in these patients. Thank you.
Wow, you can take a breath now.
Thank you.
That was a lot to get through. Probably got time for one quick question. One quick question. The quick question that I had was the GP6 levels are associated with an increased potential for bleeding, alongside particularly with assistive devices. What are the clinical implications, or are there potential clinical implications coming out of that research? Very quickly.
Yeah, so like I said, that the soluble GP6 level measurements can lead to, or we can predict actually the bleeding outcome. So currently, yes, this is being seen as a marker to predict bleeding risk,
Yep.
and it is coming in the clinical implication very soon.
Great.
To measure it.
Okay, thank you.
Thank you.
Okay, so our next speaker is Brittany Harity. She's from the University of Canberra, and she's looking at the effects of medium-chain triglycerides on cardiovascular disease and risk markers, and she's undertaken a systematic review around that.
Thank you. Thank you for the opportunity to present here. Good afternoon. My name is Brittany Harity, and I'm presenting from the University of Canberra on the effects of medium-chain triglycerides on cardiovascular disease risk markers. Cardiovascular disease is a leading cause of death in Australia. The biomarkers for developing cardiovascular disease include total cholesterol, plasma lipoprotein cholesterol that includes HDL, LDL, VLDL and IDL, obesity, plasma triglycerol, C-reactive protein and apolipoproteins. The phenotypical features include body weight. There has been, over years, increased interest in the effect of medium-chain triglycerides in terms of health benefits, suggesting that the composition of the fatty acid is important in how it's metabolised within the body. Since MCTs are saturated fat, they have been considered unhealthy, and high intakes may contribute to the development of cardiovascular disease due to the rise in cholesterol, particularly LDL. But because of the composition of MCT, this may not be the case. MCTs are now being marketed as healthy, and in particular used on the ketogenic diet. But what exactly are they, and how are they metabolised within the body? Medium-chain triglycerides are a saturated fat that are composed of 6 to 12 carbons. Coconut oil is comprised of 60% MCT of 8 to 12 carbons, and lauric acid is the main MCT found within coconut oil. Studies have suggested this doesn't contribute to cardiovascular disease or fat accumulation, and the reason for this is because of the way it's oxidised within the body faster than any of the other fatty acids. When MCTs are consumed orally, they are transported from the small intestine to the liver, where they enter the mitochondria and are oxidised to ketones in excess. They are then used for energy for the heart, brain and muscle. Medium-chain fatty acids have been used for weight loss due to the increase in energy expenditure, and have shown to improve cardiomyopathies, treat pancreatic and bile acid insufficiency in premature children and adults, and fat malabsorption. Due to their increase in their popularity, the aim of this study was to investigate the effects of oral supplementation of MCT on cardiovascular disease risk markers in humans. Following the PRISMA 2009 guidelines, all literature searches were conducted across 4 databases until August 2017. The primary risk markers was cholesterol, triglycerides and lipoproteins. Secondary risk markers was weight, body composition, blood pressure and insulin. Exclusion criteria was less than 4-week time period. A total of 2,123 articles were identified using the key search terms from the electronic databases. After exclusion and duplicates as per the exclusion criteria, 11 were included for a full synthesis. 10 looked at the effects of cholesterol and or triglycerides, 3 on apolipoprotein concentrations, 4 on insulin levels, 5 changes in body weight. Doses of MCT range from 10 to 40 grams with the longest study duration of 16 weeks. The findings from the total cholesterol and triglyceride outcome. 2 studies measured cholesterol and triglycerides, finding a significant decrease when comparing LCT and MCT effects. 1 study found a gradual decrease in total blood cholesterol in the MCT group across time. St. Ange's study found similar effects on total cholesterol when comparing olive oil to MCT in subjects consuming a calorie-restricted diet. This goes against the study by Desai, which was a 2-period crossover study between lauric acid and MCT, finding a significant increase in total cholesterol. Carter's study also found that when comparing palm oil and MCT to sunflower oil diet, MCT and palm oil produced total cholesterol concentrations significantly higher than those of the sunflower oil diet. Triglycerol was significantly higher in the MCT diet than the palm oil or the sunflower. Additionally, a study by Askarov compared corn oil with MCT, finding in subjects who consumed a test meal at the end of either 100% corn oil or 100% MCT oil diet, fasting total cholesterol was significantly higher by 16% with the MCT than the corn oil, and remained significantly higher during the fat absorption phase. Desai's study found an increase in LDL pre and post period, and Carter's study also found an increase in LDL, but showed VLDL concentrations the highest during the MCT oil diet in comparison to palm or sunflower oil diet. 2 studies found a significant decrease in LDL for the MCT group, and Hahn's study found a decrease in HDL concentrations for MCT, while St. Ange's study found an increase by 16 weeks. The 3 studies that looked at apolipoprotein found no significant difference when administration of MCT. Effects of MCT on insulin. 3 studies reported insulin levels based on a calorie-restricted diet, ranging from 2,400 to 7,600 kilojoules a day for men and women. And Hahn's study found fasting insulin concentration progressively decreased on day 90 in the MCT group. The 5 studies that measured changes on body weight after administration of MCT found a significant decrease in body weight and body fat loss. I won't go through the statistics, but if you want that, I can send you the slides after. The varied effect of MCT have on the primary outcomes could be for several reasons, such as the differences in doses of MCT and the different dietary methods used, such as the type of oil. Furthermore, the studies had diverse populations, including individuals from different ethnic backgrounds, individuals with hypercholesterolemia, insulin resistance, type 2 diabetes, overweight and obesity, and 6 studies were predominantly of the female population. In addition, these studies consist of a small sample size potentially affecting any significant changes in cardiovascular disease risk factors. Participants within 5 studies consumed their normal diets in addition to MCT dosage given, which may affect the end result of MCT in relation to the cardiovascular disease risk markers. 3 studies looked at participants on a calorie-restricted diet, which all had an impact on the amount of weight loss, therefore could also affect the cardiovascular biomarkers such as insulin and cholesterol, which indicates that loss in body weight could be contributed to a low-calorie diet rather than the MCT itself. Furthermore, physical activity would have been an impact, especially in the studies that investigated MCT effect on their weight loss. MCT is known to have some negative side effects when taken in high doses. 2 studies found mild symptoms such as abdominal cramps, bloating, fluctuations, constipation, which subsided in the duration of the study, but may impact on the absorption. Literature suggested that when MCT is the main dietary source, it may reduce the absorption of long-chain triglycerides, thus creating a deficiency and leading to changes in lipid profile, such as increase in triglycerides. So therefore, there's no sufficient evidence to suggest that MCT has an adverse or positive effect on cardiovascular disease risk markers. Studies have shown MCT consumption can lead to weight loss. However, further trials should be conducted to investigate the effect of MCT supplementation on a range of cardiovascular conditions, including more of the male population, looking at the chain length of the MCT and a longer duration of study to make a formal conclusion. Future studies may also like to see if MCT improves mental focus and clarity, as this is a marketing point for sellers. Thank you, and I'd like to acknowledge all the hard work put in from the authors across the unis.
Fantastic. Again, we've got time for a quick question. So my daughter works at a health food shop. She likes to bring home coconut oil. Should we be keeping the coconut oil in the cupboard, or should we be actually cooking with it?
That depends. I think
That's perfect answer.
as a graduate dietitian, I think everything in moderation. you're going to use coconut oil, it's probably going to be the same as if you use butter or any of the other oils, but it comes down to obviously the amount that you're cooking it with.
Excellent answer.
Well, excuse me. Thank you. Good talk. What were the designs of the studies? Were they randomized, these studies?
I'll have to look back into it. A couple of them were randomised, I
Okay.
think 2, but not all of them were. So, yeah.
I'm just wondering if the randomized were different from the observational. Then that's all in the conclusions generated.
Yeah, we were actually looking at, because we're publishing it, we're looking at putting a meta-analysis, so we'll be able to compare all of that.
Okay, great. Thank you.
Yeah.
Excellent. Okay, so we're running a couple of minutes over time. So we've got now an opportunity for a health break. I think there might be some tea and coffee, I hope. No? Well, no, we're just standing up. All right. So no tea and coffee. I'm sorry about that. So we've got about a 5-minute break. Just have a chat, stretch, make sure we don't get DVT, and we'll move on from there.
Okay, everyone up again, if that's okay. Go to the room or do something, but let's just stand and have a bit of a wiggle and get our kind of, are we ready to do the 5 sit-ups? 5 seat-ups?
Seat-ups.
Okay. I can see a couple of people standing. What about you guys? Come on, join in the fun. Because we've got to do this, just get our bodies moving again. Okay, we'll do 5. Okay, let's go. 1, 2, 3, 4, and 5. Okay, now just stretch up in the air. Beautiful. And out to the side. Normally, if you're in a room, I would get you to do a windmill, as in literally more exercise than that. But I won't. And just out to the front, just to get people moving, because we have been sitting for a while all day. And that's it. We're doing a great dance. Okay. And then what I was going to do is for all of you on the left side, walk up to you over here. Come on, we'll make a walk up to the stairs. I was going to make you climb the stairs.
Just be careful.
Okay, I'll go on going up the stairs and then walk back again. We'll just get up late or come around. Get things moving. We can actually go up the stairs if you want. Let's just do some cardiovascular. Okay. We're going up the stairs. Everyone? We'll go maybe we'll go down and then go up the other one as well.
This is good though, it can't sort of need to step up and, even just having a giggle while you're doing it, actually.
Okay,
Minimises
I'm following you. You're going to show unless you want to keep on going.
I've been standing all day. Excellent. Hello, Rebecca. But I can be more obvious than that. Brief is fine, then we have plenty of time for questions.
Anything I need to know about this? Just arrows? You can advance the science with the mouse, the space, with the arrow. Okay. Anything goes wrong, just go down.
Okay, so we are going to move along. We're running about 5 minutes late. That's why we cut this break short somewhat. But that's all right. Please remember that this is being live streamed at the ACT Health website /charm. And also, if you're into social media, to use the hashtag #CHARM2018. I'd like to now introduce Rebecca Sesnek. She's an exercise physiologist with ACT Health. She's going to be talking about the 6-minute walk test here in Canberra and the evaluation of that. Rebecca.
Hi everyone, how are we going today? So my name's Beck and I'm one of the exercise physiologists that's involved with the heart function rehab program here at ACT Health. Helping me out on this project were Mark McManus, who's the CNC of cardiology, and also Louise Gainsford, who's the other exercise physiologist who was working on the project with me at the time. The heart function rehab team all are involved in helping to collect the data that we collect and present today. But I'd also like to thank the Chief Allied Health Office, as they were the ones who provided the Allied Health Research Grant, which made doing this evaluation possible. So chronic heart failure is a progressive cardiac condition where the heart is pretty much unable to pump sufficiently to satisfy the needs of the body. It can be caused by previous heart attacks, hypertension, valve disease. It can be congenital, idiopathic, or as a result of lifestyle factors. It can affect a large number of the Australian population. As you can see up there, it affects about 2% of the Australian population each year and results in a large number of deaths. Within ACT, it affects about 7,200 each year and costs almost $30 million just in hospital costs alone, not counting other healthcare associated costs there. So as you can see, it's a condition that is quite prevalent and also has a big impact on individual's life when they're diagnosed with it, but also the carers and the healthcare system surrounding it. So the Heart Function Rehab program is run at ACT Health. It's coordinated by the cardiology department and cardiology nurses, and is run with exercise physiologists and physiotherapy input as well. The program was previously known as the Heart Failure Rehab program, however it was changed to be more friendly to consumers, but also to align with other global programs that were similar. The program runs for 12 weeks worth of supervised exercise programs, and in those people come twice per week, so on a Tuesday and a Thursday. The program runs for roughly 2 hours with an initial check-in and assessment, some exercise involved as well. During the exercise sessions, there's a staff to patient ratio of 1:4 to ensure patient safety. So that's usually 2 nurses, a physiotherapist and an exercise physiologist available for every session to help with monitoring symptoms and the exercise program itself as well. Education sessions are completed each week, and these are completed by dietitians, psychologists, nurses, occupational therapists, exercise physiologists and pharmacists. And they just rotate through that 12-week period so that patients experience education sessions, all the education sessions that are there. As well as the 12-week program, we also do review appointments following up on the patient to ensure that they are continuing to stay stable medically, but also they are continuing their exercise habits as well. And these are done 3, 6 and 12 months post the supervised sessions that are there. We do collect a variety of outcome measures that are up there, both pre and post the supervised program, and then some of these are also completed at the review appointments, but not all. So the aim of the Heart Function Rehab program is primarily to look at a behaviour change. We know that exercise has a substantial effect on the number of hospital admissions that a patient with heart function can have, their functional ability, as well as their medical status too. And with the nurses there, we're able to look at a lot of the other risk factors that these patients might have and pick up on any changes that might be happening before they might occur and trying to prevent them from getting into hospital. Obviously, we're looking at some of the other exercise goals, such as improving their aerobic fitness, improving their strength, their ability to complete their ADLs or their activities of daily living as well. The group has up to about 15 patients in each group, so it's a great social aspect for people to see what other people are going through, and we do know that some of them actually continue to meet up to do their exercise afterwards, which is really nice to see. So the exercise guidelines for patients with chronic heart failure is a combination of both aerobic and resistance exercise. With aerobic exercise, we should be looking at most days of the week, 5 if not all of them, for at least 30 minutes each day, aiming up towards the 60 minutes if someone possibly can. However, because of their compromised cardiac function, CHF patients may not always be able to get this in. We're looking at a moderate intensity, so if anyone has heard of the RPE scale, that's a validated self-reported scale that patients use in terms of how hard they feel like they're working. It can either be between 6 and 20, but we use a 0 to 10 scale for patient ease. This is where they feel like they can notice that their breathing has changed, or they might be starting to puff out loud, but they could still talk to you comfortably. With their resistance exercises, we're looking for 2 to 3 times per week, trying to get some peripheral adaptations there and increase their oxygen uptake, as well as increasing some strength gains where possible. Lots of different types of equipment that can be used for resistance-based exercise, which we go through with the patients throughout their sessions there, trying to look at what they can continue ongoing. So some will like to go towards a gym, whereas others will prefer to do things at home. So we try to set them up with what's most appropriate for them. To collect data for this evaluation, we used ACPAS and CRIS. We collected information on their attendance, 6-minute walk test outcomes. We used quality of life questionnaires, both pre and post the 12-week program, and also CHF knowledge questionnaires to see whether the education sessions were effective or not. We also looked at their exercise participation levels, both throughout the program and at the reviews at the end as well. We did have challenges with collecting some of the data, considering this was all done retrospectively. Not all of the data was available there for us to use, so we ended up analysing the information on the physical activity outcomes, particularly the 6-minute walk test, as well as exercise adherence. So in terms of the participation rates of heart function rehab, we had 53 patients come through in the 2-year period that we did the study. As you can see, as the time progressed, we had a significant drop-off in patients attending. This is quite common according to literature for heart failure patients. However, usually they do still sit about the 50% attendance rate at their reviews, according to literature, whereas we were down to about 35% by the time it got to the 6 and 12-month follow-up reviews. There was a fairly even split of male to female by the time we got to the end of the review appointment, whereas at the start there were a lot more males in the group. And the age range stayed fairly standard throughout, indicating that there wasn't a significant drop-off of either the older or younger population that was in there. When we were looking at the adherence to exercise recommendations throughout the reviews, we actually found that with aerobic exercise, as people attended ongoing reviews, it started to increase. So at the first review, 3 months post the program, 50% of people attended. That increased up to 54 by the 6-month review, and at 12 months it had gone up to 65% roughly as well. However, we did notice that with the resistance exercise program, this actually started to decrease. So it went from 50 down to the 41% mark, indicating that this is something that we might need to look at in our discharge planning, as patients obviously aren't adhering to the resistance exercise guidelines quite as well there. The research indicated that patients with this population have a fairly similar adherence to healthy populations in terms of ongoing exercise adherence following a supervised program, which typically does sit around the 60% mark. So our aerobic exercise was sitting about right by the end of the 12-month review, but resistance wasn't quite meeting those marks there. Looking at average 6-minute walk distance throughout, so for those who haven't heard of the 6-minute walk test before, it's a validated aerobic function test where the patient walks at their own pace but aiming to walk as quickly as possible for 6 minutes on flat ground. We measure their oxygen, their heart rate, and again their RPE, so that self-reported value of how hard they feel like they're working. Before patients came into the program at baseline, we were averaging about 350 metres. However, it continually increased up throughout the reviews, which is great to say. So this is, I guess, showing us that their functional capacity continued to improve in those ones that did continue to attend their reviews. However, in saying that, the ones who attended the reviews are also likely to be the ones that continued exercising as well. So it's not surprising that there was an increase in their values there by the 12-month mark. It was great to see, however, between the baseline and the 12-week 6-minute walk test that there was a statistically significant change in 6-minute walk test values, as well as this, the minimum clinical significant distance, according to literature for this population, is 32 metres, and every single one of our patients achieved this mark as well. There's also literature out there showing that if someone is unable to walk at least 300 metres in that 6-minute time difference, that they have a decreased survival rate, and all of our patients were reaching over 300 metres by the 12-week mark at the end of those supervised sessions. So, in summary, I guess, while attendance at the supervised sessions was high, we had we had only 20% not continue, so we had 80% complete their supervised sessions. Attendance did decrease as they went through their review periods, down to almost 35%. So we've made some changes within our administration follow-up to try and increase adherence to these. However, there is definitely still more work to go on this. Adherence to exercise guidelines range between 40 and 65%. As I said, aerobic was better than resistance in this capacity, so we need to have a look at what we're doing from a resistance exercise point of view and how we can continue this ongoing after patients have finished these supervised sessions. Obviously, we were unable to get any data for those patients that didn't attend their review appointments. However, I would expect that these guys probably weren't continuing to exercise as much. A lot of the programs that we used in terms of reviewing this literature and doing analysis only did follow-up up until 12 months post-initiation of the program, whereas we did 12 months following completion of the program. So we actually had an extra 3 months of follow-up in there. So we are now looking at determining whether it is required to continue this. The number of patients that actually attended at both the 6 and the 12-month review were exactly the same, and they were the same patients. So whether that shows that patients were needing to have that ongoing follow-up or not remains to be seen. However, as we did see, the changes in exercise adherence did go up and down quite significantly. So we're continuing to work on that at the moment. We've also started to look at changing our data processes in order to make these kind of evaluations easier for the future. Thank you.
Thanks, Beck. 6 minutes? No. Beck was worried that she wasn't going to be able to speak for longer than 6 minutes. I guarantee that she did. Look, one quick question. Are there any quick questions?
Can you elaborate more on the problems with the data collection and how we can improve on that now?
Yeah.
And what's been put in place to improve the data collection?
Yeah, definitely. So at the time, some of the forms that we used weren't clinical forms. So for example, the review forms that we used often weren't uploaded onto CRIS just because they weren't a standardised clinical form, which meant that we didn't have any of that information available to us. At that period in time, there were also some changes in terms of, I guess, the ownership of the program and moving from hard copy files into soft copy files. So not all of the patient's data was available to us or was available to be sourced from there. So we've now started to use some spreadsheets where we're tracking things as soon as a patient is discharged from the program and trying to keep on top of that. However, given that the program doesn't have any administration support, that is deeming challenging at the moment. So,
Great. Thank you, Beck. I'd now like to introduce Daniela Gagliardi. She is from the ACT PHN. She is fantastic. And she's going to talk about the Heart Failure Care Initiative around that. So I'll start with Daniela.
Yep, thank you very much. Good afternoon, everyone, and thank you to the Heart Foundation in providing the opportunity for me to come and present on our Heart Failure Care Initiative. Before I begin, I would like to acknowledge that we are meeting on the land of the Ngunnawal people and pay our respects to their elders, both past and present. Heart failure places a significant burden of disease on the Canberra population, yet despite advances in heart failure management, clinical outcomes remain poor. And as Beck has just mentioned, that in the ACT there were 7,200 cases identified last year of people living with heart failure, and there is an associated cost of $44 million. Heart failure is also considered one of the most potentially preventable hospitalisations and readmissions. Heart failure can be a complex condition to manage due to ongoing medication titration, symptom monitoring, and patient self-management, which can result in disconnected and fragmented care. Traditionally in the ACT, heart failure management is predominantly specialist focused, which can place a significant burden on our acute services. However, alternative models of care that promote integrated care and team-based care in collaboration with general practice are beginning to gain prominence. So utilising the 2013 Heart Foundation Consensus Statement, which sets out recommendations to deliver comprehensive heart failure care, The Heart Failure Care Initiative aims to develop and implement a comprehensive and systematic approach to the management of heart failure within the ACT that involves evidence-based, multidisciplinary and patient-centred care. This is a joint initiative in partnership with ACT Health, the Heart Foundation and Healthcare Consumers Association. We have adapted a 4-phase approach which is focused on the establishment of a heart failure clinical leadership forum to lead the initiative, the development and co-design of an integrated heart failure model of care and associated outcomes framework, and the next phase will look at pilot testing some of the key priority components of the model of care across the next 12 months. We have also engaged a formative evaluation team to conduct a formative evaluation across the duration of the initiative. Right from the beginning, it was crucial that we wanted the initiative to be clinician-led. Therefore, we brought together clinical leads across the ACT, spanning the public and private sector, across cardiology, general practice, rehabilitation, pharmacy, allied health, palliative care and emergency. The 25 members of the Leadership Forum are dedicated and committed, understanding the local system challenges and are solution focused to improve the outcomes for consumers in the ACT. In collaboration with the Clinical Leadership Forum, a health consultancy service undertook an intensive co-design process which involved reviewing the current ACT heart failure service model, a review of palliative care approaches, gap analysis and identifying areas for improvement. This was also informed by a series of key stakeholder consultations. Based on the review results, an intensive series of co-design workshops were held to design and develop the model of care design principles, patient pathways and prototype of the model, and testing the prototype model with real patient case studies. Even though we had a consumer representation on the Clinical Leadership Forum, we wanted to ensure that we had broader engagement of consumers during the design process. So we partnered with Healthcare Consumers Association to facilitate a series of focus group sessions, and in total we had 14 people living with heart failure, the carers and families participating in those sessions, and their input really helped to inform the model of care. That co-design period culminated in the development of a patient-centred model of care, which is underpinned by 12 key components, facilitating early diagnosis and interventions, self-management, interprofessional collaboration and care coordination. Central to the model is the establishment of a heart failure hub, which would provide the structure for coordinating a more comprehensive team-based approach for patients across 3 areas, including management, education and rapid assessment. Other key components include establishing the role of community-based heart failure nurses, improving medication management and improving data collection and utilisation of existing patient data both in the hospital and general practice setting. The model of care also focuses on addressing the gaps identified during the design stage by clinicians and consumers around improving care coordination and communication between heart failure nurses, GPs and specialists around the patient's needs, clarifying roles and responsibilities of the care team to ensure patient-centred, seamless, team-based care, and improving education around patient self-management strategies and supported self-care. The model is also complemented by an outcomes framework which encompasses both patient and system-level indicators of effective heart failure care. These were based on recommendations from the Heart Foundation and the International Consortium for Health Outcome Measures. Now endorsed by the Clinical Leadership Forum and project partners, both clinicians and consumers are keen to ensure that the model of care is realised. There were 41 recommendations put forward to mobilise the model of care, and a number of clinician-led working groups were established to identify which ones were the priority areas and develop those associated interventions which we could begin to pilot. With support from general practices, the Heart Function Clinic and cardiologists at Canberra Hospital. These priority areas include increasing access to timely and accurate diagnosis by developing a new referral form and protocol for fast-track access to echocardiograms, developing tools and resources that improve communication and team-based care, such as a heart failure cycle of care checklist, a roles and responsibilities guide, a medication titration plan, and end-stage heart failure palliative care protocols. Enhancing transitions of care and improve patient self-management by developing a comprehensive patient-led heart failure care plan, including goal setting and action plans, and focusing on workforce development and optimisation strategies for heart failure care, which we're planning a series of targeted education sessions for practice nurses and GPs. In conclusion, the heart failure model of care provides a framework for best practice heart failure care tailored to both the ACT population and our local service system. It's founded on evidence-based models of chronic disease management and can also provide a blueprint for the development of other chronic condition-specific models of care and co-design processes. Through the next phase, we plan to finalise and pilot test the priority interventions with general practice and Canberra Hospital through effective implementation strategies. Overall, aiming to enhance patient health outcomes, improve the patient experience across the system of care, and reduce avoidable demand on our local health services. Thank you.
Great, thanks so much, Daniela. Are there any questions? I guess, oh, yes.
What do you plan on doing for the formative evaluation?
Sorry, I missed the beginning of that.
What do you plan on doing for the formative evaluation?
Yep. So the formative evaluation team that we've engaged with, the first half of their evaluation actually focused on the co-design process that we undertook with the Clinical Leadership Forum. So they were actually quite involved during that co-design process and conducted interviews and also conducted a survey with the clinical leads to ascertain their views on how the co-design process actually went and to actually determine whether or not the model of care was actually fit for purpose. The second half of their evaluation will now focus on the pilot program as well, and we'll also mainly be looking at the processes that are undertaken during the pilot, so looking at any barriers or enablers to how we are progressing with implementing those key interventions. And the final report will also look at on how we can upscale the pilot and actually look at rolling it out to other general practices as well, and also look at the sustainability. Yep.
Excellent. Great. Thank you. Thanks, Daniela. Okay, so our next presenter is Katie Spear. Katie's from the University of Canberra. And she's going to be looking at heart rate variability in children that's influenced by moderate to vigorous exercise in maternal exercise and nutrition and smoking during pregnancy. So, Katie, thank you.
Thank you. Good afternoon, everyone. My name's Katie Spear. I'm going to talk to you about my review entitled Heart Rate Variability in Children Influenced by Moderate to Vigorous Maternal Exercise, Nutrition, and Smoking During Gestation. As the leading cause of death worldwide, cardiovascular disease is largely associated with older adults and places an undeniable burden on the individual, their families, and public health care costs. In 2011, CVD contributed to 56% of total deaths in Australia, and this may largely be due to modifiable lifestyle risk factors such as physical inactivity, poor diet, and smoking. Unfortunately, with our changing lifestyles, we're now seeing these risk factors in children. For example, in the ACT, 81% of children do not meet the recommended physical activity guidelines. The dangers of developing these risk factors in early childhood not only affects immediate physiological and psychological health, but also quality of life later on, as the chances of these risk factors persisting into adulthood is extremely high. Current research shows that the autonomic nervous system is dysregulated in CVD, and the modifiable risk factors I spoke of before are also known to unfavorably alter ANS function. Modifiable risk factors, ANS dysfunction, and cardiovascular disease may be associated since the autonomic nervous system acts as the communication line between the brain and the body, with the ultimate goal of maintaining homeostasis through its sympathetic and parasympathetic branches. When homeostasis is compromised due to constant stress, autonomic function is altered due to allostatic load, which may then eventually lead to cardiovascular disease. Fortunately, heart rate variability, which captures the time between heartbeats, is a non-invasive and accurate technique that gives insight into autonomic activity, tracking health and disease, and rendering early detection and prevention of cardiovascular disease achievable. And while this relationship has been examined in adults, research into the effects of modifiable CVD risk factors on autonomic control in children under 6 years of age is extremely limited. So with this in mind, we performed a systematic review examining the effect of modifiable risk factors on the heart rate variability of young children as a determinant of CVD risk. The potential impact of this research is that identifying the strongest modifiable CVD risk factors as early as possible may improve long-term individual and public health outcomes. And heart rate variability may be the method to identify children at risk. 5 databases were searched for this review for studies between 1996 and 2018 that examined autonomic function of children between 28 weeks gestational age and 6 years old. Mothers were also included as participants, and studies were excluded if all participants had any health conditions known to impact on autonomic function or did not analyze autonomic function via heart rate variability, time, or frequency domains. So we followed the PRISMA guidelines, and 22 full-text articles were assessed for eligibility. The main reason for excluding articles was that they didn't examine autonomic function of children in the required age range in relation to CVD modifiable risk factors. In total, 10 articles fulfilled inclusion criteria and 8 showed significant impact. 6 of the articles looked at the child's heart rate variability in relation to the mother's modifiable lifestyle risk factors, and the remaining 4 looked at the child's own influence. Most studies looked at physical inactivity, followed by poor diet, and 1 study looked at smoking. For the effects of maternal risk factor influence, lower blood levels of omega-3 fatty acid status during pregnancy was associated with lower infant heart rate variability detected at 2 weeks until 6 months after birth. This indicates a weak autonomic nervous system. With respect to exercise, women who didn't exercise at least 3 times a week for 30 minutes duration each session throughout gestation had children it resulted in a decreased total heart rate variability of both the fetus and an infant at 1 month of age. Lastly, mothers who smoked during pregnancy but not after was associated with a lower heart rate variability as reflected by an increased sympathetic activity and decreased parasympathetic activity when compared to the heart rate variability of infants who were not exposed to smoke in utero. Regarding studies focusing on the child's CVD risk factors, there were mixed findings, with 2 out of 3 studies demonstrating that diet affects heart rate variability such that infants fed an omega-3 deficient diet had lower heart rate variability, as did malnourished children. The 3rd study didn't find significant results between the heart rate variability of infants given 3 months of fish oil supplements when compared to the controls who weren't given any supplementation. The 1 study looking at the effects of physical activity and metabolic profile on heart rate variability didn't find significant results. So despite promising results that the autonomic nervous system of young children is influenced by modifiable CVD risk factors, there's insufficient evidence to support the strength of this association, given the lack of studies on the risk factors in the children themselves. The studies weren't without limitations, including the time of day that the heart rate variability recording took place wasn't controlled for, as well as a lack of control for confounding variables known to influence heart rate variability. Interestingly, the fact that all included studies looking at the effects of maternal risk factors on the heart rate variability of their child demonstrated significant results may point to a possible pre-programming effect such that regular exercise, a good diet, and a non-smoking environment may play a beneficial role in programming the autonomic nervous system of the child and thus later cardiovascular health. So in conclusion, the findings from this review highlight the importance of omega-3 fatty acid intake, regular maternal exercise, and a non-smoking environment to reduce CVD risk in children. This research also supports the use of heart rate variability in future pediatric studies to assess CVD risk. Future studies should try to validate the most reliable method of measuring heart rate variability in young children, and they should try to do this in a longitudinal design. It may also be beneficial to look at the effects of paternal modifiable CVD risk factors on the child as well. Thank you very much for the opportunity.
Fantastic. Thank you, Katie. Are there any questions from the floor? Okay, so my quick question. The next phase of research, how would you, or well, where would you like to take your research so far, and how would you take it? How would you take it to that next stage? What are the things that we need to look at in terms of, you know, you've mentioned good diet, regular exercise, and smoking. We know that they're good for people. How are we going to look at that in younger children as well?
Yeah. So I guess like I said, we should definitely try to validate a method there's different commercially available methods of measuring heart rate variability. None of them have been looked at in kids, and that would be the first place to look, since all of those risk factors can be looked at through heart rate variability. So really determining which one is the best to use on young children would be the way to go.
Excellent. Fantastic. Thank you. Thanks very much, Katie. Okay, so our next speaker is Brett Schultz. He's from the ANU. Excellent, thanks, Brett. And he's looking at, not in the room, a story of completion study of consumer representation. So I'm really interested to know where this is heading. Thanks, Brett.
Thanks for that. Hi, I'm Brett Schultz. I'm a research fellow at the medical school at the ANU, and I'm co-presenting today with Peter Head, who was supported by the ACT Health Research Office in a vacation scholarship at the start of the year. So I'll hand over to Pete to introduce the study.
Sure, thanks, Brett. So at the moment, the current Australian mental health policy requires that consumers are to be involved in every aspect of mental health services. So research has shown that there's a number of benefits to this involvement, including greater holistic care, greater quality of care, and also greater accountability and credibility of the services themselves. So now one of the most widely used forms of involvement is through consumer representatives, and these are people who act on behalf of other consumers. So now the aim of this paper is simply to develop a clearer understanding and improve our understanding of how consumer representatives are perceived compared to mental health professionals, specifically in their case when a change in organisational priorities are proposed. Now to do this, we did a qualitative study in the form of a survey. There were 34 participants. 21 of the respondents were consumers, 8 were mental health professionals, and 5 identified as both being a mental health professional as well as a consumer themselves. So now, I think the interesting part of this study, at least, was the fact that it was using a story completion method. So this involves us forming a story stem, which kind of gives a bit of a background and introduction to the story, and then asks respondents to fill out that story however they wish, really. So an example of a story stem we used is this. This looks at the perception of the clinical professional, so I'll just read it out. Dr. Evans is a clinical representative on the committee of the local mental health service. Alex, a new consumer representative, has joined the committee and arrives for their first meeting. At the start of the meeting, Alex asked the chair to add a new item to the agenda. Please write the run-up to the meeting, what the agenda item is about, and how Alex prepares for it. So now, one of the important things about story completion is that it's used as a form of a projective test and to try to gather information that respondents might not typically give in a more traditional research method such as interview or focus groups. And lastly from me is we analyse this using thematic analysis to really try to highlight the underlying themes that were in the responses themselves. And we did this following the methodology from Brown and Clark. Pass it back now to Dr. Schultz.
Thanks, Pete. So I'm just going to go through our results, and there were 3 aspects of the data that I'm going to share with you. There was a lot more than this, but I've tried to pick some that I think might be more relevant to most of the people in this room as health professionals or people involved in healthcare. So the 3 aspects of the findings included that consumer representative roles are still not valued, and I've got some data that I'll talk to about each of these aspects shortly. The second part is that co-production isn't occurring, even though consumer representatives are in place to co-produce health services. Our data suggests that that's still not the dominant narrative, it's still not the story that's being told about how consumers are being involved. And last of all, sort of a hopeful thing about how, as health professionals or people involved in health, how we can include consumer representatives more meaningfully. So I'll talk about each of these aspects, and instead of using my words, I've got much more interesting words from the participants that I wanted to share. So first of all, in terms of not valuing consumer representative roles, one participant wrote, Alex wanted to discuss the impact on patients, but the others in the room assumed that Alex, as a consumer representative, wouldn't have anything to add about what they considered an internal problem. So a lot of the common kind of ways of talking about consumer representatives in the data was that they were outsiders, that the other people in the room, who constructing them sort of as more professional than the consumer representatives, were often making the decisions about how consumer representatives would be included. So here we can see Alex wanted to discuss, but it was the others who decided that Alex couldn't discuss. And that was quite common through a lot of the stories. The second aspect of the data about co-production not occurring, again, I'll show you an example from a participant who said, Alex was not in the room, but the doctors were in the room. The situation seemed like the setup of a bad joke. Alex smirked, composed himself, and walked into the room full of doctors. So another really common theme throughout a lot of this, a lot of the stories that were completed was that there was only ever one consumer, even though participants could write whatever they wanted. There was only ever one consumer in the room, and I think that actually reflects what we found in a lot of our other research about consumer representation. I mean, and in this case, there wasn't even one consumer in the room. Alex was not in the room. There was definitely a sense through a lot of the data about space belonging to health professionals, and when consumer representatives came into that space, it was never their space. It was a medical or a professional kind of space that they were excluded from. But the last theme, I have a nice sort of, I was only able to choose one example, but there were more examples of how consumer representatives were more meaningfully included. So one participant wrote, Alex felt disappointed that his input was not recorded in the minutes. When the secretary sent out the minutes, Alex replied by email to add in his perspective that the issue did not just apply to staff of the hospital, but to others using hospital services too. So this kind of way of, there were many ways in which consumer characters in these stories got inclusion back, whether it be by sort of subversive means like this, such as emailing somebody to make sure that they were included in the minutes after meetings. Another way that meaningful inclusion was presented in one of the stories that I was tossing up between presenting as well was in a Christmas party in one of the stories, that the consumer representative and the chair of the committee were rapping together and drinking or something. So there were stories of inclusion, and I think that's important to focus on as I discuss some of the implications and what I think we need to be thinking about as health professionals or people who are kind of involved in this space. So there's three ways, and they're kind of related. The first way is through allyship, and the stories in which health professionals were able to use their power to create space or make spaces for consumer representatives often led to better inclusion. So whether that be through things like, encouraging consumers to email or be subversive, or whether that be through working with consumers on subcommittees to make sure that that gets fed up to the bigger committees. I think we also need to be thinking about resources in terms of how resources, particularly in terms of space and hospital spaces or other health spaces, are often seen to be not the domain of consumers but the domain of health professionals. And I think we need to, as health professionals, challenge that and make them more inclusive spaces. And last of all, through subversion and thinking about other really nifty subversive ways that we can challenge the power structures that have been that have kind of led to consumers not being in the room. All right, I know I've already gone over time, so I'll leave it there, but thank you.
Thanks, Brett and Pete. Any questions from the floor?
That was fascinating. You reported on 3 themes. What were the other themes?
So there was so much in the data. We've just submitted a paper focusing on those 3 in particular. So they're also the ones that were fresh in my mind. But some of the other things included there was a lot about power and sort of nuances of who controlled agendas and also about, I guess this is tied in with power, but another one of the issues that I was really interested in was knowledge. So consumer representatives were often portrayed as needing to go that extra mile to find knowledge or back up their knowledge from sources, whereas the other health professional characters in the stories didn't have to find anything to support it. Their knowledge was treated as sort of taken for granted. Thanks.
Fantastic. A really fascinating study, I think. I'm really keen to read that paper when it comes out.
Thank you.
Excellent. So thank you very much. So we are about 10 minutes over time, but that's okay. We've saved one of the best to last. This Professor Deb Lupton. She's a centenary research professor at the University of Canberra. She's author of 16 books, 160 book chapters. She looks at sociology, media and cultural studies. And today she's going to be talking about the Australian Women and Digital Health Project. Deb.
Thanks, Anthony. So I'm doing this unplugged. I don't have a PowerPoint and I have a piece of paper, even though I'm a digital sociologist, so I just like to confound expectations sometimes. I'm a sociologist, so I'm interested in the social and cultural and political aspects of health and illness, and I'm also a digital sociologist, so I'm interested in how people use digital technologies, and I'm bringing those together in a lot of interests together in a lot of projects at the moment, looking at sociology of digital health. So what I want to talk about today is a project called the Australian Women and Digital Health Project. And it's a qualitative research project that actually has quite a bit of a component from Canberra, so women living here in Canberra, but also women living in other parts of Australia. So there's 2 studies in this project. The first study is the Canberra-based study, and that include interviews and focus groups with a total of 36 women here in Canberra across a range of age groups. And then I decided, having done that part of the research, I was interested in seeing, what might women in other parts of Australia be thinking and doing and saying about digital health. So I got a market research company to do a telephone qualitative interview-based study using the same questions as I used with the Canberra women, asking them about their use of digital health. And they were in every state in Australia, those other women, and again a range of age groups, because I was really interested in looking at how people might use digital health across those ages, from early adulthood right through into their 70s. And in fact, the age range of the whole group, which was a total of 66 women for both studies, was from 21 to 73. So quite a good diverse age range there. So in terms of why am I interested in women? Well, when you think about digital technologies, they're often designed and directed towards men. It's often a very small demographic that actually generates devices and software, and they often live in a very small geographical area, i.e. Silicon Valley in California. And they tend to be white, middle class, highly educated men. What this means is that sometimes digital technologies, whether they're health oriented or otherwise, aren't designed with a female user in mind, and that has led to some controversies, such as when the first Apple Watch was introduced. There was criticism of it because it had various apps for self-tracking already uploaded to the watch, but it had no menstrual tracking, and menstrual tracking apps are very popular tracking apps amongst women of reproductive ages. So there was a criticism there of Apple that they hadn't even thought about what women users might want. So that's one of the key issues that I was interested in. What is the fact that, what are women looking for, and how are they using digital health technologies? So the questions that I asked women in focus groups and interviews focused across the whole range of digital technologies that they might be using. And I have got hardly any time to actually talk about the findings, but what I want to go straight into is my health record, because that is actually been a very controversial electronic health record of recent times, as we all know from now that the opt-out process has been introduced. And even though these interviews and focus groups were conducted before this year, I was interested, because I was interested, I knew that this opt-out period was happening, so I had a question there about my health record. Now, what I found was very interesting. Most people didn't know anything about my health record. It was kind of off their radar. So only 1/3 had signed up to my health record out of this group of women around Australia. Some people just weren't sure. They said, well, what's my health record? I've got no idea if I've signed up or not. Half of them had said that either they hadn't heard of my health record or they deliberately had not signed up to my health record. And when asking them more about it, those people who were quite against my health record, the issues there were they didn't trust the government, basically. They said that the government is incompetent rather than malicious. They didn't see that the government was trying to exploit their data, although that has been some of the privacy concerns around my health record. But they just thought the government couldn't do it well, that they were bumbling people, to put it politely. So I thought that was an interesting finding, and I think that can kind of contribute to our understanding now of why it is that people might not be interested in signing up or to my health record, and why that was a problem for the Australian Digital Health Agency. What else came out was that across the age groups and across where people lived, everyone was Googling madly, Googling health issues madly. Didn't matter how old they were. They absolutely used Google to find health-related information. They were often doing it on behalf of someone else, so there was this caring element that they were looking for information about health for their children, including adult children, which was interesting. They're still having that caring role with their adult children, for their partners, for their elderly parents, so across a range of family members. They were Googling also for those people. Health and fitness apps were used by about half of the group. And interestingly, it was not just the younger people who were using health and fitness apps. Middle-aged women were quite keen users of Fitbit and other calorie tracking and fitness tracking apps. Social media was used by about 1/3 of women for health-related information and for sharing information about health, and Facebook was particularly dominant there. So Facebook groups were used by a lot of women. Some of them were very keen users. They had up to 25 memberships of Facebook groups, and often these were women with chronic health conditions or women who were in the early years of parenting, and they really relied on those Facebook groups. They were an incredible source of support for these women. Some women had started up their own groups and finding that they were benefiting a lot from sharing their own interest and expertise with other women. Having said that, women certainly were not, there's been a lot of concern in the medical profession about Dr. Google and cyberchondria and so forth, but I found in this research that women were absolutely not distrustful of their doctors. They were still very much willing to rely on the expertise of medical practitioners. And in fact, they were using Googling as a way of sort of triaging. They were using Google to go online and see, well, is this something I should be worried about? Are these symptoms something that I need to see a doctor about? And they were absolutely happy if they decided that they should go and see a doctor, that they did so. So it was not like they were rejecting medical expertise, it was sort of complementary to medical expertise, and in fact it was helping them decide whether they need to go to the time and effort to go and see a doctor, because of course the convenience of Google is what was really underpinning people's common use of it. 30 seconds. Finally, one interesting and unexpected finding was that even though women were tending to use digital media most often to find health and medical information, whereas before they may have used handbooks or they may have used newspaper articles or even television documentaries, they were hardly using those sources of media anymore for health-related information. They were absolutely going online or they were using apps. Pamphlets came out as a common source of information. And this is because, there's my timer, this is because when women did go to the doctor, they were waiting in waiting rooms for quite some time often, as is the case, and they were picking up pamphlets. So that's just something to bear in mind, that is an old-style, traditional medium that actually is still used by quite a lot of women. Thank you.
Wow, fantastic. Thank you, Deb. I'm asking for a friend. No, I'm really interested that people were not trusting of the government, but they're willing to give their data over to Facebook, Fitbit. You know, is there not a
cognitive dissonance?
Yeah, perhaps. Yeah.
Term you're looking for. It's really interesting. Every study I do, because I'm interested in data privacy, it doesn't matter what the topic is, I ask people about their data. People still, it doesn't matter who they are, their age, their gender, they don't tend to worry about the data that they upload to Google search or to apps or Facebook, other social media, because they don't actually see that as a threat. What the big issue was with my health record data was, again, the perceived incompetence of the government. They'd seen things like robo-debt happen, they'd seen census fail. You know, we've had quite a few scandals and events around the government not being that competent around protecting people's data or doing it well. So that was, I think that's a difference. But it's a very interesting difference, I think.
Yeah. Any other questions coming out of this? Because I've got plenty, but I'm really cognizant of the time. It's about 4:10. We were supposed to finish at 4, so I will cut it off there. But I'm confident that there's going to be plenty more questions coming out of that.
Thank you.
I would once again like to thank Deb for being our final presenter. But I'd also very much like to thank you all here today for coming in throughout the day, and for those people who've been watching online, thank you. And for those people who've been participating through social media, thank you as well. Thanks to Charm and the Heart Foundation for a fantastic day. There's another 2 days of the Canberra Health Annual Research Meeting to go ahead, and so I'd encourage you all to come along tomorrow and the next day and just see some of the great research that's happening here in Canberra and beyond. So thank you very much.